Hello everyone and welcome to part 7. In this part we're gonna upgrade a few things about our project, namely our build system and access to record structures. As you can see in this piece of code here, when you have nested records, the access becomes very clunky and unwieldy, and we're gonna use lens concept and lens library to change that into something that closely resembles object-oriented, or you could say C-like procedural data access. First thing first, let's upgrade from cabal to stack, something we should have done a long time ago, and I stuck with cabal simply because habit. We're gonna do this by first updating the stack system, and then init. As you can see, sometimes it's gonna happen that stack doesn't cover one of the libraries on a package, and in this case I generally just use this option to set it up. Excellent. So we got this new file, stack YAML, and here you can change. Okay, so quick explanation. What stack does is it creates build plans, which are, as far as I understand, lists of all the packages on package, or at least the packages that stack supports. As you can see, ncurses was not supported at the moment. And it makes sure that certain versions build with dependencies from certain versions, so you cannot end up in a problem that was called cabal hell, where different libraries in your project depend on different versions of themselves. So, for example, you need two libraries, but they both depend on a third library, but on different versions. Stack solves this so that basically you just, instead of typing versions in your cabal file, you just type the names of libraries here, and you type your resolver up here, and you're gonna get the newest version of the libraries that work well together. Anyway, after this is done, let's see if we can build. This is gonna take a while, and in the meantime, let's go look up for lens. Excellent. Well, while it's building, we can work. So the second upgrade is going to be lens. That means we have to add it to our cabal file. Lens. Okay, so there's two parts to lenses. There's using them, and there's creating them. Lenses are just normal functions that are set up in a way so that you can use the dot operator to chain them together to access nested structures. You'll see it's very easy, and it's very it looks a lot like what other languages have. But there's a shortcut to making lenses so that you don't, for example, if you have a structure like this that we have here, a record, not a structure, you would, in order to access each one of these fields, you would need to make a lens for each one of these fields manually. Basically, this is 1, 2, 3, 6, 8 functions. What we're gonna do, we're gonna enable an extension of the GHC compiler, and we're gonna use this template Haskell function to generate lenses for us automatically. And we do that very simply. We do this: make lenses, palette, That's it. It looks awkward because it's a template Haskell instruction. It's not normal Haskell code. The other requirement is that for every record field that you want to create a lens for, you need to underscore it. So this function is gonna go through this data type, find all record functions that have underscore and create lenses for them. That's it. So let's prepare that up front. For some reason my auto-completion is not running. I don't know why. It may be because this thing is building, but I'm not even seeing the you complete me menu. No, there it is. Okay, but the Neko is not running. Weird. Anyway, it doesn't matter. Alright, that's it. So let's go to places where we do have a record access, and I guess the best place to do is to look for the these braces. There, this is an excellent place. So as you can see, what we're doing, this is a typical state function. It takes some value, and then it takes the old, this would be, let's call it a modifying value, and then the last two parameters of the function, well, actually the last parameter and then the output, is of the same type, and this is the old value, this is going to be the new value. This is a typical pattern of a state function, and when you're using lenses, the very simple way of you can very simply just omit this parameter eta, reduce your whole function, and let's see what we're doing here. So we want the inventory to be modified to append one more item. Excellent. So this is a synonym of this, and we have a lens that supports exactly this, and I think the lens is no, this. So this is a lens operator. There are, I'm gonna very quickly explain, there are roughly 3 general groups of lens operators: the ones that start with a dot, the ones that start with no, am I wrong? No, pardon. The ones that use tilde, these are the setters. And for example, this thing sets, the lens goes on the left, the value goes on the right. This sets the value into this lens. This is a modification where this thing isn't a value, this is a function that takes old value and produces new value, right? You have versions of this that look like that. Lens value. This is why I'm saying it's a pattern, and these things work inside a monad state and do exactly the same thing. And you have this one that retrieves a value. In this case, pardon me, the lens go on this side, and this is the root record. So what we want to do here, we don't need monad state access, so we know we need one of the tilde family functions, and we want either to modify it because we're not setting a value. We could set, for example, write that we want to set the inventory into this, but as you see, we could modify the inventory by just applying this function to it, like that. There's an easier way where we can just find the lens that does appending, and I'm sure there's one because I used it. Let's just see where it is. And it's probably gonna have, okay, maybe in setters. No. There you go. So you see that our A type, basically our output lens type, has to be a monoid. The lens goes first, the monoid value goes second, and the third is the actual lens root record, which is the thing that we ETA reduced in here. So to append something to the inventory, we need this. And it kind of makes sense, right? Because this is the monoid append or a semi-group append operator, and then you have a tilde, which is a setter operator. And you can see the same pattern goes in here. You have the OR operator and a setter. So eventually you're gonna get an idea how these operators you're gonna get the idea how these operators create groups, and you're just gonna from your head figure out which one to use. So what we need, we want inventory to append I, and that's it. This is, so let's try to explain once again. Our record function, so the built-in record function, is now underscore inventory, right? When we access the inventory here, ignore this part for now. This is a lens function which you can't see in our source code because it's generated in the precompile step by make lenses function. Inventory type is a lens that takes character A as an input and returns you back a list of A outputs. So we take this lens, and you know what, let's just make this so that the things are clear. Just for now. We take this lens and we want to say that the field that the lens reference to, we want to modify it so that we append to it. And this creates a function that can be executed on a lens type that has character as the input. And then we just apply character to this and we get the character out. Okay? This is why we can ETA reduce, because with lenses that are not monadic, we can simply just omit the last parameter, you know, and that's it. The compile failed, obviously, because we're changing things. Let's try that once again. Excellent. And see, as it says here, inventory is not a record selector, and right down here we're using it as a record selector, and we need to change it. Okay. So again, in here, what we're doing, we're modifying the inventory, right? And the modifying function is again a setter. So, and as I explained before, it's usually this operator, the percentage sign, means that you're gonna, on the other side, get a function that takes the old value in and you have to produce a new value. So the type of this is going to be A towards A. Okay? Because our inventory is a list of something, there's a lot of functions that in the preload that look exactly like this, and one of them is our delete function. So we can replace this whole thing. It looked like this. First we can remove. Okay, let's go like this. Modify by delete E, and this works. And then we can just ETA reduce the C out and done. Build. The problem now is that we changed everything to use the lenses, and you know what? Let's upgrade this one by one. I don't see the necessity, for example, the palette for now to be assembled of lenses. Maybe later on, then we're gonna have to change it, but for now, let's just leave it. Yes, of course, we need this operator. Okay, so the old game has running set to false. Okay, so here we're setting a value to something, so we're gonna use this lens. We cannot ETA reduce the OG here for the simple reason that the implementations of the function, they have to have the same amount of parameters. So if I remove the OG here, I will have to remove it from all top pattern matches. But that's okay, we can just leave it on the end. Okay. Let's do the rest. Set status here. See again, a state function. It's here, reduce here. We're gonna of course need this pattern. So you see, set the value by using the append from the monoid. Set the value using the state function. Set the value. This thing is probably implemented as a const function over this. It's very simple. Avatar. Okay, so avatar, this is the thing. Avatar now is not a record function, it's a lens. So we need to pick the avatar in a different way. And I'm not even sure that we necessarily need set status function anymore, because it's just a simple setter. So right here we can do something different. So what we're doing, we're setting the status of the avatar, right? Okay. So debug status is gonna be show okay. Now we need the view lens here. So this is how you extract the data from a lens. This operator right here. As you can see, it's the dot is on the opposite side than in the setter lens. But I'm feeling that we can do this in a better way. I'm gonna use the views. These two are almost the synonyms. View Views, the only thing that's the difference, okay, so you have a view function and view, and these, they are synonyms. It's just that this acts as a function, this acts as an operator. Views, it does the same thing, but it also takes a function to transform immediately whatever you're looking at. And that's what we're doing. As you see, I'm asking for the avatar and then I'm applying show to it. So the way I'm gonna do it, it's gonna be view, avatar, modified by show, and game is our last parameter. So we can remove all of this. And the last thing I'd like to do is to somehow eliminate a G, and we could do that. Let's replace this with a setter, and I think it's called a set. No, just set. Yeah, as you see, set and this value are synonyms. And the reason why I'm gonna use the function instead of the operator is because I want to combine. Okay, set debug status to avatar G, and if this is a function that takes a G, I could ETA reduce G and then combine them using this operator. I want to say that this is going to work, but I'm not sure. No. Okay. Well, whatever. I can't be bothered with this right now. G. G. So we can change this completely. Display character status. Super simple. So we need position of our avatar. So we're gonna change it. We need OG as our root lens and our root structure, and we want the avatar position. This is very interesting because I didn't show how to nest, how to access the nested data, but this is the first time we do it. As you can see, this looks very much OOP or any nested structure access, but this this is just the function composition operator that composes the avatar lens function and position lens function, and it has a higher precedence than this operator. So these two get composed first, and then this operator applies that function and this record, and you get out exactly what you would expect. Same thing here. Same thing here, is just a different thing. So we need map and then map data, and this is stored in our game record. Same here, we want map with stored in the okay. Yes. You're gonna have to, when you do manual exports, you're gonna have to remember to export your lens function as well. Because as I say, they're just normal functions that are generated in a precompiled step. And there you go. What I usually do, as you can see, I don't export everything. If I have lenses, then I try to enforce usage of lenses across my code. So the record functions are not exported whatsoever. Sure. Excellent. So we want to modify the old game, and we want to set the avatar to become something new. Okay, so we're setting the avatar to become entity. And we're getting the avatar object. Remember that avatar is stored as the entity that has position and an object. And object. Okay. So we want to do two things here. We want to modify both the avatar and items. So we're gonna have avatar modify avatar, modify avatar object, add to inventory, and then it's the object that we're picking up, and this would be the old avatar, but we don't need it because this lens operator sends the old, it asks you for a state function, right? So you see add to inventory takes a value, which is our value here, and then it's a state function, and this state function is exactly what this operator asks. So we've done that, and what we need to modify is items. So items, we want to replace the objects. And we don't need the old items because again we're using the state function. And in the end of this, it's the old game. Okay. This is easy. The way to turn a record, to turn a lens into standard record function very simply is to just use the synonym of this operator that we used all around, and the synonym is view. And that's it. I just need to add it here. Remember the difference between view and views is that a view just turns lens into a record function, and views also takes an additional function that converts whatever the value is. OG items. You know, this could probably be refactored way better through using lenses. I'm just doing like make it compile thing right now. So object should become RV. And as I say here, super simply, g get map, g items, get avatar position, and then give us the debug status. Okay. Exactly, because we want to show the avatar, and avatar is our A parameter. So A has to have constraint. There you go. Stack complaints if you don't add all your modules in a list. So I'm gonna do that now. There you go. Notice one thing. I usually use stack install to immediately copy my thing, and as you can see it copies it in your local executable directory. So after that you can execute it from anywhere in the system. And that's it. As you can see, this is how the lenses work. Mind you, one thing which I started using as a practice, I consider lens, this is nice and neat, but I consider them more as an implementation strategy rather than an interface. What does this mean? It means that whenever I'm interacting with a code like this, I don't want to have access to the internals of a data structure. What I want is an API on top that acts like a little language, domain-specific language that I can run probably as a monad that's going to convert the data structure into something new. This is what we're going to be doing next time. Instead of this is the best scene right here, right? As you can see, we're applying two lens modifications, two lens setters to our old game in sequence. But because they're sequencing here, just the pattern of this code shows you that it would work very well as a monad. So yeah, that's what we're gonna do. Instead of having functions that have these state patterns at the end, we're gonna create a function that, as a constraint, returns some kind of a game API monad, and the game API is gonna provide you with functions that can do certain things to the game, and obviously it's gonna produce this game API value that then has to be ran to modify the game structure however you want to do it. Whether you want this API to act as a monad or you want it to act as a functor, this is all going to be solved through constraints at the place of the site. You're going to see next time. But for now, I hope that you see the benefits of the lenses and how they really help you deal with nested structures, something that happens a lot in large projects. So until part 8, I'll see you soon.